Good morning, afternoon, and evening, everyone, and welcome to another session of Microsoft Zero to Hero Community Series. Thank you all for joining us today from different parts of, I would say, the world. My name is Puya, Microsoft Security MVP, MCT, and Community Leader in Microsoft Hero. So before having our great speaker on the stage, I'm going to couple of actually code of conduct of our community, and then we're going to have Senthamil on the stage. So as you know, the Microsoft Learn community is an ideal space to build your skills, connect with the Microsoft experts, and receive genuine support throughout your learning journey. So the Microsoft Learn community is the perfect place to grow your skills and make it sure you are receiving the right information from the right expertise. Just a couple of actually code of conduct rules. So be friendly and respectful to everyone, listen to different opinions, and be kind and patient when you're asking some question or you're receiving your answers. Don't forget to follow us on LinkedIn, YouTube, and Microsoft Tech Community to receive latest news and updates about our community and upcoming sessions in following months. So it's my pleasure to host today's sessions. AI Unleashed, the Foundry and Studios shaping tomorrow's creativity. Today, we are joined by a very special speaker from Singapore, Senthamil. Senthamil is a passionate Microsoft community contributor, speaker, and Microsoft MVP who has been actively helping professionals and broader tech community understand and adopt Microsoft technologies across AI, Azure, Power Platform, Copilot, and automation solutions. We are really excited to have him with us today and looking forward to learning from his insights and experience. Please join me welcoming Senthamil from Singapore. How are you today, Senthamil?
Hello, hi. I'm good. Thank you for joining the Zero to Hero session. Thank you for having me on this session. Yeah,
Thank
thank you so
you.
much.
Thank you for joining us and sharing your experience with everyone and your expertise and insights with everyone in the community. That's great to have you today here. So without further delay, I would love actually to bring your slide up. And I'm behind of the stage. Let me know if you needed anything. But at the end of these sessions, people, if you're watching now, we are going actually to some questions and answers. You feel free to post your questions in the chat window. We get Senthamil to answer some of those questions. Thank you. Senthamil, the stage is yours.
Okay, thank you. Hope you can see my screens here. Yeah. Thank you everyone for joining me on the Zero to Hero session. So today I'm going to speak more about the AI Unleashed, mostly on the Foundry, and I'm going to discuss more on the case study which I'm working on the AI Foundry as well as the Microsoft models which I use it on the day-to-day activities for my projects. Later, I would give you more details on those project as well. This is just brief about myself. You can see I'm more of a Power Platform consultant and the Microsoft MVP for almost 12 to 13 years. I live in Singapore. I do more on Power Platform these days and Microsoft Foundry project connecting to the LLM and Microsoft models more on the AI as well. I also have wide experience on the Microsoft platform and the stack. Anything on the SharePoint, Microsoft Teams, and Power Platform, you can get in touch with me. These days, I do more on the Copilot Studio as well, connecting more and more agents and creating agents, deploying to the enterprise. So for the today agenda, I have a few things to discuss on this. Especially, I would go through on the Microsoft Foundry. Most of the people who are attending would know what is Microsoft Foundry is now. I would discuss more on the Microsoft Foundry. Next, I would discuss more on Microsoft Foundry portal, how it looks like and what are the things you can see on. And the current strategy for the developer, especially for the architects to work more and more on the AI is the MCP server. I would discuss more on the MCP server as well. I would deep dive into one of my use case using Microsoft Foundry as well as the MCP servers. Finally, I would just go through some of the key takeaways, how it shapes the real projects or the real use case which you go through on the Microsoft Foundry. As you can see here, I just give you the basics of the Microsoft Foundry. Most people might have known about Microsoft Foundry is last time Microsoft, there is a kind of history towards the Microsoft Foundry. Last time Microsoft had it as an Azure AI Studio. It started all about the AI Studio, where you can collate all the models, have it as a playground, instantiate your models, and finally you create your chatbots. So basically, Microsoft started creating as a Azure AI Studio as a kind of a, chatbot to initiate. Then the chatbot becomes more and more intelligent. You have more of a model added to it. Then it becomes more like a store. You buy your model, then you instantiate your model. Finally, you explicit as a API, then you can connect to your models. So that's how the Microsoft looks like. Currently, it has been renamed as Microsoft Foundry now. Previously, it was called Azure AI Studio. Now it has become Microsoft Foundry. It is a single place for all the model catalog. You can see all the models, all the open AI models, irrespective of the publisher. You would see most of the models. If you want to use Claude, you can use it. If you want to use your DeepSeek, you can use it. So you just instantiate your model, you pay based on your usage. So basically all the models, it is by the token. When you instantiate a model and start using it, it is charged based on the token based. So that's how the model catalog comes in. Next, the prompt flow. So the visual orchestration of the LLM chains, you can easily visualize all your LLM, how it goes through, what are your prompts, what are the users typing on the prompts. It gives you the full information about your end-to-end information on the telemetry, on how to use the prompts within the Microsoft Foundry. This is the one place where you can find out what are the prompts which has been given by the people based on the model. The people can switch between the models if you have a choice to. Like in my case, when I was doing a project, we usually have a ChatGPT 2.0 plus the Cloud Anthropic model. Basically, it switches between the model. So when there is a orchestration happening between the planning and the execution, you could see all the telemetry on what are the planning goes on, and later you can fine tune the model as well. So next time when you go through those models, you can fine tune those models based on the output of the model telemetry as well. So basically what happens is that when someone gives you a prompt, the prompt goes into the LLM, it goes searches into your data source, depends on the data source you have configured, and it crawls into your data source, and finally it brings in your result, and it does the grounding based on the model it has been configured, and gives it to the user. So these cycles, if you want to fine tune based on the telemetry, it is easier through the Microsoft Foundry. Microsoft Foundry, what it does is that it gives you the full telemetry of all your models which you have been using in, and finally you can just fine tune based on the metrics which it has provided in. Finally, there is an evaluation which goes through the groundedness, relevance, and the coherence based on the telemetry which it captures. Then you can fine tune and deploy the model based on your model. One other options which you see from your uh, Microsoft Foundry is that back in my use case, which I'm going to discuss on currently, what it does is that when you start to consume the model gets you the result. and these results may not be useful to the user. In a scenario where somebody wants to get the latest information from the financial uh, catalog, so what it does is that the model goes into the system, identifies the data source. Within the data source, it grounds your information, and the moment when it grounds the information, those information might not be relevant enough. Like for example, if you are querying something related to the financial information which is to be submitted to the past, like last year, what is your financial information related to the IRA submission? So those are the old information which sometime the model might not have it on the current relevant stuff. So at that time, your information which is pulled from the financial statement might not be more relevant. So during that scenarios, your model output can be something which is not completely relevant to your information. So at that scenario, what it happens is that the fine tune information and the evaluation, you really have to check whether the previous statements or the last year statements, does it really make sense? You'll have to really fine tune your model such a way that your model should understand in a financial world, the date doesn't matter. What matter is more of how the statement relates to the information which it brings in at the last time. So for example, last year submission of your IRA statement, the tax statement, it may be the outdated date, something like uh, December 2025, but still that is the relevant information to be pulled in and shown to you now. Why? Because you have submitted your IRA statement or the financial information last year, which is more relevant to you now, and you'll have to act on it and process it based on those information. So something which the date uh, key becomes a very key information for your financial information. So those kind of information, when you try to do the groundness plus the relevance, it has to fine tune based on your use case scenarios. So that's how we fine tune our model as well as evaluate our model. So those becomes much easier when you do the Microsoft Foundry, and the Microsoft Foundry really gives you the full understanding on how to uh, move around with those information. Next is about how the Microsoft Foundry really helpful. They really have a playground. The playground is nothing but you start instantiating a model, feed in your information, upload your data. Like for example, if you are capturing an information from the PDF, you upload your PDF, and it becomes a playground. And the playground gives you a real feel of what would be the output of your Microsoft Foundry information from. For example, in our scenario, what we did is that we instantiated two models, which is the ChatGPT 2.0 and the Claude uh, Anthropic Claude, and we try to understand from what is the output would it comes from the playground. Claude Opus, or whatever the model comes from the cloud, which is really good in the planning, and the ChatGPT 2.0 or the ChatGPT models are really good in execution. So what we really do in the orchestration layer is that we always give feed information to the cloud to plan it out. Once the plan is given to the cloud ChatGPT, then it executes it. Those orchestration those orchestration has to be really played around in the playground before even you move it to the production. So at that time, we do the side by side model comparison, try to understand the relevance, and try to understand their score, and try to understand how the model behaves. So those kind of information you can really do that at the playground, and before you publish it to the production or even to the staging. And these information are very key information which decides what model to use at what scenarios. Last time we are trying out several models like the Claude Haiku, DeepSeek, and several other models to identify their metrics. Then finally we settled in with planning for the Opus and ChatGPT. So ChatGPT really made it for execution, and the Opus for the planning. And the prompt flows again, Depends on the uh, model which you are using. Then you go for the LLM orchestration, as well as how do you want to deploy those models within. You use the CI/CD pipeline and integration and the flows as well. Finally, the deployment, it makes it much easier to deploy. For the models, you just deploy it as an API with the API key. Then any application, it can be your Python application, it can be your TypeScript, it can be your any end-to-end application, which just make use of your model based on your API. So in our scenario, what we do is that we deploy it as an MCP server. Later, I will discuss more on the MCP server. The MCP server would uh, expose it as an endpoint, and these endpoints will be consumed at your front end. Then you can just make use of it. So next we see more on the MCP server. So what happens is that whatever you want to deploy it, the models which you deploy, those models might not be sufficient enough. Those models has to be configured and custom made, and it has to be learned custom. And there is a scenario called you want to expose your set of information as a kind of a MCP server. If you see here, what is an MCP server? MCP server is nothing but long back we have been speaking about the REST API, and these REST API been published all over the world. Example, take a scenario of the money exchange and also the weather scenarios. Long back, people used to use web services or the service oriented architecture, SOA. People started publishing more and more APIs to consume and make use of it. So right now, if you see XE has the mobile or the currency exchange, and you also have several REST API for the weather. You have a REST API for the flight details and the timing. There are so many global REST APIs which are already there. The problem with the REST API is that it is built for developer. So the developer has to feed in the information like in the JSON format, and the output is in the JSON format. It is not built for AI. AI would understand, but still it needs a developer to come in, feed in the information to the REST API. It is a post call or the get call. Then the information will be shared along. So when the time goes on and the way AI comes in, the AI find it slightly difficult to understand those REST API, and you need to consume that REST API. That's how the MCP server comes in. So the MCP server is nothing but those REST API are converted into tools. They call it as a tool, and these tools are nothing but the APIs which has the description, and it tells AI that what kind of tools it exposes in, and what kind of parameter it can pass in, and what kind of information it can bring it back. Imagine that if AI knows how to call those tools, the AI can make a decision on what tool to call. Example, a scenario where there is a weather, and the weather information takes in a location sometime it takes the GPS location, sometime it takes the postal code, sometime it takes the city code, sometime it takes the country code. So these get weather information can be published in several format like a tool. So whenever a person or whenever there is a query or whenever there is a LLM query asking for, hey, get me a weather for Singapore. So suddenly the AI knows that Singapore, it is a country. So it knows what tool to invoke in, like get the weather for a country. That's it, it pass in. Sometime I might ask like, hey, give me a weather for my current location. So at that time, it is like the current location, it is specific to a location inside a Singapore. Like for example, it can be a Changi airport or it can be some other location. So at that time, it knows it has to identify the GPS or by the postal code or by the location. So the AI would decide what tool to invoke based on the query. So this time it knows that it is a location within the Singapore. So it selects the tool what it can do. So basically these tools are nothing but the APIs, but exposes to AI in such a way that, hey, I'm here to give you the weather for a location. So the AI knows that, okay, this tool is to get the weather for given a particular location. So that's how the AI decides on. That's how the whole architecture goes in. And also the LLM models, it depends on the models again. Some models are smart enough to decide what tools to call in. Some model you have to plan it properly. Like in the Opus, it plans what tool to consume, then it invokes into the MCP server. So the query comes into the LLM, the MCP, it hits into the MCP server. You can see here, it hits into the MCP server. So once it hits into the MCP server, then the query decides on, the AI decides on what API or the tool to call from. Once the tool is executed, then the output is being processed. Again, the output is the same as the JSON format. Most of the AI tool knows what how to process the JSON. So they process the JSON and then get the output. So the key capability, if you see here, there is a studio, which is like the Azure MCP server or the Foundry. You can even publish your own MCP server. These MCP servers are nothing but kind of an endpoint. It doesn't have to be a full end-to-end server. You can even publish it as an Azure functions. So these Azure functions can be the endpoint being invoked. Inside that, it can process your information and then can be informed. It can be a container being published, and also it can be a serverless endpoint. So it's up to you how do you design this MCP server. And there is a tool discovery, which I mentioned you. These tools are nothing but the API. Like in my scenarios where you want to get the weather of it, this tool discovery is nothing but getting the information of the weather. And the AI decides, or the LLM decides what tool to be invoked. The tool has the schema, and this schema has to be passed. Like in the case of getting the weather for a particular location, the schema should identify the particular location. It has to pass the GPS or the postal code or a city or a location within the country or in a city. So that's how the schema works in, and the capability is basically on the runtime. And also you can see that there is a enterprise authentication you can pass in. Sometimes you can publish those tool as a public API or a public tool. You don't need an authentication. But if certain things you want to query something like which are more sensitive enough, you can add a enterprise authentication, especially the OAuth authentication on top of the tools. So the MCP server should, or the LLM should really authenticate it, get the token, and finally you should understand what tool to invoke in. There is also a multi-tool chaining, meaning that there can be a multiple MCP servers. Like take a scenario where I want to identify uh, identify the flight timing and details of the airport. So in that scenario, you'll have to cross through multiple MCP server. I'll have to first identify what is the flight number, and based on the flight detail, it has to get the source on the destination airport, and by the airport code, it has to go through that region, and based on the region, then it has to get the details of that particular source on the destination. So in that scenario, you'll have to cross through multiple MCP server. Each MCP server might expose a different tools, and these tools can be invoked based on the multi-tool chaining. And these multi-tool chaining is based on orchestration. Either it can be sequential or parallel. Like if you want to identify a flight arriving at Singapore or leaving at Singapore, then it has to be sequential. Why? Because you'll have to first identify the flight number, then get the detail, then go to the MCP server where it gives you the location information. This should has to be sequential. But think of like whether you want to identify uh, once the flight arrives at the destination of Singapore, you want to know more about the Singapore terminals and where your luggages is going to be, and what are the things you can do it in Singapore, and what are the information you can get it from the Singapore terminal. Those information can be parallel, because it doesn't matter whether you arrive it in Singapore or not. You want to know more about the Singapore terminals plus your flight information plus other details. So in that scenario, it can be parallel. You just give a query to the prompt, and the model decides on what tools to invoke and get the information, and this can be parallel, and it's a tool chain, and it can invoke it parallelly to get the information about the terminal, get the information about your arrival details plus all the information which are on the arrival airport. Yeah, so that's how it works on the MCP server. This is more of a MCP architecture which you can see and learn on about it. Okay, so there are several MCP servers which are already Microsoft have published it. So you would see those MCP servers in, let's see here. So by the category, you would see that there are MCP M365 Frontier servers, which are more of a Frontier program. Frontier program is nothing but as a special program you subscribe. Only then you have access to those MCP servers. Microsoft is still developing on those MCP servers. You don't have a public access, but you'll have to sign up to the Frontier program. One of the thing is that the Outlook MCP servers for the communication, where you can do more on querying your Outlook information using the KQL and manage your Outlook. Similarly, for the Teams, you can able to manage your chat channels and the members. Also, there is a content storage, which is the SharePoint. There is a special SharePoint MCP server to manage your SharePoint and the OneDrive. And also, you can do the SharePoint list and the CRUD. Next thing is about the identity under search. You can have your Azure Graph API or the Graph, where you can have your Copilot search and other stuff manages by the identity server, MCP server. Azure MCP server is again there. Like for example, if you want to query your subscription information, the Azure MCP server is already being published, and you can use 320 plus tools to query your resources being deployed into your Azure. Like what are the firewall which has been placed into your enterprise on this pipeline, you can find out. What are the VM which are more consumed, or which VM which takes up more of resources and try to consume more costs, you can find out. So those kind of the MCP server, we can find it out. Microsoft Foundry, again, there are several Microsoft Foundry MCP server which are also there. Also, there is a Microsoft Fabric MCP server. Next to that is a developer and the business, where you have a DevOps, Azure DevOps MCP server to play around with the DevOps teams, and then the Power Platform MCP labs. There is a business apps MCP server where you can play around with the Dataverse, Dynamics, and all the Dynamics product as well. So all these MCP servers will work out only within the Copilot Studio. You cannot make use of it outside of the Copilot Studio, from my experience. So from the Copilot Studio, if you want to create an agent to make it more smarter to understand about your Azure, especially like you want to create an agent and publish it into your enterprise, and if a user wants to query anything related to your resources being deployed to Azure, then in that case, you go to Azure Copilot Studio, instantiate an agent, connect it to your Azure MCP server, then good to go. Any questions which you ask around the Azure MCP server, that's it. It will answer. It will straight away start to answer it. Yeah. So that's how it works with the SharePoint MCP server as well as your other MCP servers. let's go into the deep dive of the financial and the financial web scraping tool which we have developed using the MCP server. So this is one of the use case I really want to uh, discuss on this scenarios, wherein there is a problem statement which comes out like we want to scrap multiple documents from all over the websites. You can see here there is a fund administrator. They manually download all the financial statements from 50 plus portal, and they collate all the information. So each portal they'll have to log in manually and then download the PDF of the capital call and different format statements and distribution data and all the statements, and manually they have to input. So they have to collect per day. You might receive around uh, 10 to 20 documents from different portals. So each document you have to go through manually, identify the numbers, and finally you have to key it into your dashboard. It takes around uh, 15 plus hours is like minimal, but you'll have to go through uh, kind of one full day to identify all those documents, make sure that those documents are good enough, process it, and then upload it to your dashboard to to the end customer to see it. That becomes very problematic. That is the main problem which we are facing in. So the solution we come up with is that there is a MCP server which will which can easily identify your websites. It can crawl into your website and then download all the documents. It can download the document based on your schedule. It can download the document based on your details. And the GPT, whatever the models which we use based on the Microsoft Foundry, it can go to the documents and make it as a structured data. It crawls into the document, identifies the document metadata and the structure. It saves into your Azure blob, and finally it can extract all the keywords and make it more structured. Like for example, if you want to identify all the Q4 or the Q3 capital call documents, then it can easily identify based on the metadata. So that's how the documents have been scavenged. And then the prompt chain. So next is about how do you get those information within the document and then save it into your metadata plus your dashboard. So these amount, dates, and the fund information, basically any document which is downloaded, which has the fund name, whatever the investor which they have, also when the document has been published and the document date plus your document information. These are the key information for the financial related information, and it can download. Also the automated dashboard updates via the API. If you are done by the human, it takes a very long time to identify the document and update. If it is done through the AI and the API, it is much easier for them to crawl, do the metadata, and finally it can download the document from there. So how do we implement it? So the implementation takes deeper into the AI, because by the time when we were starting the project, it was like the AI was very primitive. We used we started with the ChatGPT model, which was very primitive. Now we are in the advanced model of Claude, Opus plus the Chat GPT. The Opus does all the planning, and the ChatGPT does the execution. So the key things about the MCP browser tool. So what it does is that there is a MCP separate playwright tool from Microsoft. This MCP playwright tool, it can be cloned from the GitHub Microsoft site, and you can customize such a way that you can make it to work for yourself. These MCP server tool can be deployed as a separate container within the Azure Web Apps. The Azure Web Apps has a separate container services. You can deploy that as a container services. Additional tools, especially someone prompt saying that, hey, log into this portal identify the document and extract only the capital call document and the distribution notice document. So those kind of a custom prompt, if you want to do, you create your MCP server, then you create multiple tools within the MCP server using your Playwright as your engine. So the Playwright becomes an engine. We created our own manual tools, published it within the MCP server, and then just put it into the container. So any LLM, irrespective of whether it is Gemini or Copilot or any LLM tool, can interact with this MCP server. Why? Because it has all the tools which is necessary, and it can crawl into any of the website, get all the document which is necessary. It is even smarter enough to identify your current quarter. If you just blindly prompt saying, hey, get me the capital call statement, then it identifies that there is no other prompt, there is no other keyword which is that specific quarter. So it identifies that it is a current quarter. And similarly, if you say that it is a capital call document, automatically it knows that it has to identify the fund name, investor name, and the key fields within the document. And it fetches in all the information related to the capital call statement and puts it into the dashboard. So that's how the MCP server has a custom tool built in and deployed as an container. Second is about the document extraction. So these document extraction is nothing but the Azure. This is how the Microsoft Foundry comes in. So the Microsoft Foundry, we have a several model and the AI search deployed within the Azure. It identifies the documents, crawl into the websites. It knows that the first thing is that it should identify where those PDF document or the capital call statement being published inside the website. It identifies that automatically. Once it identifies it, it automatically downloads it. Once it downloads it, it knows it extracts the information like the fund name, investor name, capital call, the capital call numbers, and it also extracts how much of the information or what is the investor related detail, the fund related detail, and to whom it has to be addressed to, and what is the amount to be settled in. So all this information it captures in based on the document being uploaded into it. These are all kind of a knowledge which was acquired over a period of time. So we keep uploading the PDF. The AI knows what type of document to get in, and then it will extract it. Then finally, the LLM validation chain. This LLM validation chain will identify the extracted information which is in align with your expected information which you are in, like whether these fund name and the investor name are expected for this quarter. Yes. So then this LLM validation will go in. Also, it will flag the inconsistent data as well as the missing data. Like for this quarter, if you are expecting tax document to be applied and still you don't receive the tax document from this website, then it knows that LLM knows that, hey, by this month or by June or May, you might have received your IR document by now, but still this website has not uploaded the IR document. So just ping in. So those kind of information. Finally, updating the dashboard. So those information which are already pulled in has to be processed, and there is a REST API which AI already knows that it has to call to post the information. These post information can be queued and then be processed. So finally, about the use case and the takeaways, what it does is that Azure AI Foundry or the Microsoft Foundry unifies our entire lifecycle, AI lifecycle for the production deployment in a single platform. So basically what happened is that previously we used to have multiple platform deployed, like the cognitive services plus the model name and other information which has been deployed on. Those information will have been has to be collated and then has to be used in. So right now these AI cycle it comes under one single umbrella, then it becomes much easier for you to use the single platform again. Second thing is about MCP server. So the MCP server completely made into a single platform, and all the LLM and the real world, you just publish your tool, then it becomes much easier for us to use it, and AI can understand that easily. Yeah. Uh, Third thing about the web scraping. So right now, previously we were using the manual download. So the manual download for each website took around 1 or 2 days. It literally made two three people sitting around downloading each document, understanding the document. It takes a lot of time to download and then process the document. But once we automate through LLM, and then the LLM learns about the websites, it quickly downloads. Even when there is a new update comes into the website, it can easily go in and then just download the document. You don't have to really wait to uh, get the documents in. So the AI knows it that there is a change happened in the website. It can download the document immediately while improving the accuracy and your consistency. The last one, human in the loop validation. So those documents which are downloaded and verified and then extracted and then feed into the dashboard, it took so long to identify and verify and then to upload in. By the time when the LLM comes in, it half of the process has been done by the LLM by the time it has been identified the document. So when it logs into the server or the portal, it immediately identifies the fund name, investor, and the date, and it can narrow down the document based on what is your expected information. Like for example, now we are already in the month of the tax filing. So the LLM knows or the AI knows this is the month for the tax filing or the tax document related information to be fed in. If the portal doesn't have any of the document which is related to the tax, then immediately it will flag into the user saying, hey, uh, it is the time for you to look for all these documents in. It's already not there. So either you send out an email or you check whether you have received those document to file information for the tax. So if you have already filed in the information, then your tax information statement should have been received. So those information should be in your inbox or in your portal. So those are missing already. So check again. So those kind of a validation which can be done automatically with the AI. Similarly to the capital call and the distribution notices, those notices has to be processed already. But if there is no document processed for the last 1 month or a week, then automatically the AI can prompt to the information or to the people saying that these information or the document has to be received by now, but it is still missing. So either the portal has not received or there is no email about it. So check and then contact your customer support. So those kind of information are preemptive information which has been given by the AI. So it becomes much easier for you to get the information from. Yeah. So those are the key takeaways which we could be able to process from the MCP servers, but the Azure AI Foundry, which is completely more advanced, which we feel. Previously, if you think of like 2 years back, we struggled a lot to identify those documents, download a document, collect a document, and finally to enter into your dashboard. It take a lot of a time to process those documents. But now, with the Microsoft Foundry, the correct models which we place in, and the deployment of the MCP server, along with the orchestration of your Azure AI search plus the document processing. Now, this process takes less than a week time to process all those. So the time to time when the document comes in, it picks up the document and immediately it has been processed. Previously, we used to queue the document based on the person availability, and it completely delays the process. It took almost 1 or 2 weeks to queue the document and then identify the document and then segregate based on the people. So for a financial document which has already been there, There has to be separate uh, expertise of a people, like the one who is really expertise in the tax management, one who's really expertise in the public um, equity and other information to be know. So you really need a specific expertise people to understand the document and then process it. But now the AI understands the document irrespective of the expertise of the people. So, for example, if I just feed in the capital document, the AI knows it. If I feed in the IRAS document, it knows it, or the IR8 document, it knows it. If you feed in any of the advices notices, it knows it. So those documents are completely identified by the AI in no matter of a time. You don't really need a separate expert to identify it, analyze, and then update the document. So those times are completely cut down, and the processing has become much easier. So that's the key takeaway which we have done so far, and it has become more futuristic, and it becomes more productive. Yeah. So that's how it goes in. Yeah. So that's all from my side. Any questions or anything from?
Thanks, Senthamil. I think it was a great session and sharing some of your insights on the AI Foundry and how AI Foundry and along with the other components can help the organization to build up the AI solutions. Probably one question here is saying, of course, with many so many actually AI models available today. So, how should organizations choose the right model with Azure AI Foundry for their business use cases?
Okay, that's the question everyone will be thinking about it. So, from our experience, we started with a very primitive chat GPT model, which is like 4.0 or very primitive model from the beginning, which is like more of a chat model. Uh, 2 years back. Then successively, when we start improving our system, we identified that those model are doesn't perform well. Why? Because it is just a chat reply. So you give a chat, then it replies based on your prompt, but it is not intelligent enough. Then we started looking into more and more advanced model. So this orchestration engine, so whenever you want to design any AI solutions in enterprise, you need to decide on the orchestration model. So this orchestration model is nothing but the orchestration will decide on what model to use at depends on your prompt. Like if you use the GitHub Copilot, you just give your prompt, but the back orchestration engine decides on what model to invoke at the background. So in our scenarios, what we did is that we did more and more research based on the model telemetry, which comes from the model foundry, the Microsoft Foundry, and we saw that there is a kind of a noise or the output which is not performing well. So we started exploring more and more models. The cloud Opus seems to be very superior in planning, but very poor in execution. Why? Because when I say that, hey, I want to crawl into this website and log in using the login and download a document. That's it. The prompt was very simple enough. Login, download. But Opus is very clear enough that it identified that the website uses a username and password. So you have to log in only with the username and password. And once you log in, it identifies where the document is. And once it identifies the document, then you know how to download the document. It was so fast in planning the tasks, but when it comes to execution, it took us long time to execute it. Maybe because the Opus model is designed such a way that it is for planning. So we created an orchestration engine where you use a Opus model for planning, and then for execution, ChatGPT model. So ChatGPT model, when the plan output of a Opus model, which is just nothing but the JSON, which is a planning, you just feed it to the ChatGPT, the execution was much faster. it executed so fast than the Opus model. So it all based on the future. You keep looking into new models, whatever comes in. You study about the models. Also, the Microsoft Foundry, it has a very good telemetry. You check the noises plus the relevance plus the output of the model. Then you keep refining it. That's how we did. Yeah.
Okay, that's great. And that's exactly, I would say, is a segue to the next question that I wanted to ask, which is, because each of these models have a each is going to end up with different costs, different performance, different, latency, as you said. Sometimes it's quickly just getting back to you based on the prompt that you're sending. So based on that, how Azure AI Foundry helping to optimize the AI model performance, cost, latency, especially in the production environment when the businesses wants to have in production, how the AI Foundry can help the organization in that respect? Because you mentioned a bit of that, but I want to just get a bit of more information how the AI Foundry is helping that space.
Yes, that's one other good questions on how the Microsoft Foundry helps into cost cutting in. So basically, what happens is that Microsoft Foundry, it has a very good telemetry on how much of the token you are consuming and how much of the how the model performs really on the prompt which the user gives in. Like for example, people will beat around the bush saying that, hey, get me the latest uh, weather. Simple thing is that get me the latest weather. Okay, then you get the weather. Oh, no, get me the weather for my location. Okay, my location. No, this is not my current location. I'm currently in outside somewhere. Okay, so you keep consuming your token unnecessarily. So in that scenario, what it happens is that Microsoft Foundry really gives you the telemetry saying that, hey, these prompts are not good enough. It doesn't pinpoint to the solution where you are looking in. So it consumes more of the token, and this is the token information which is scanned. So there are two elementaries which you really look into. One is the prompt relevance, and the other one is about the token consumption. So whenever someone wants to use the AI, now is more of a token. uh, Example, when you are doing any programming or the coding, so make sure that the first time you completely understand the full project of it and save your md file .md file, so that whenever the AI starts to give you any advices or program, it always looks into that md file. That is one of the solution you have. So what it does is that it completely saves you around 30 to 40% of your token. Why? Because the AI have already done your full research on your project, and there is a .md file, and you save it into your such a way that folder, and AI mention to AI that, hey, you are a solution architect, senior developer. When you have any doubt of the project, just go into that folder and look into it. Don't ask me, or don't give me any bullshit answers. That's it.
Sure.
So something like you set the base for AI, and the base for AI you identify based on the tokens used and the irrelevant prompt which is given in the Microsoft Foundry. So Microsoft Foundry will easily start to identify it, and then it emits you the base queries or the base setup for the agent. Yeah.
Right. No, that's a very valid point, and that's what I've seen when I was just a bit playing up with the coding through the AI and just doing, which was named vibe coding. So just sometimes playing up with the coding and stuff. So no, this very valid point of having that MD file, because that instruction definitely is helping. Instead of having iterative type of back and forth with the agent, especially is developing the code and changing again because you haven't provided enough context to the agents what you want to exactly do. Of course, it's going to be back and forth, and you are burning tokens that you have available, and especially if it's going to be very expensive tokens that you're using based on the model, so it's going to be cost you much more in compared with having pre-context available to the agents as a first shot, I would say, and get everything done to the agents, and then you are just doing the optimal, or I would say tuning a bit further instead of having back and forth in the chat. So No, great points. I want to thank you again for allocating time and joining to the community to share your insights and the experience that you had using Azure AI Foundry. So thanks again for joining us, and I hope actually everyone enjoyed your session. And definitely be in touch with Senthamil if you have any specific questions from Senthamil. You can reach out directly to him on the LinkedIn or send the questions on the chat. Definitely Senthamil, we're just going to watch on that if any questions for him to answer later. Thanks again for joining, Senthamil, and thanks everyone joining online with us today. And I hope wherever you are, you have a great day and night. Thank you.
Thank you so much.